Hello, Physical Science. Today we're going to be talking about 1.3b. 1.3b is on a quantitative comparison between two or more objects. And let's get started.
When the night has come and the land is dark and the moon is the only light we'll see. No, I won't be afraid. Oh, I won't be afraid. Just as long as you stand by me.
So we're looking at 1.3b. This is a quantitative comparison. Quantitative is just like a quantity. It's comparing things with numbers. So first, if you're given a data table, when you're given a data table or a graph, that's what we're looking for. So the first one we're going to look at is the data table. When you have a data table, there are only three things that I can actually ask you. Identify the location of each object at a given time, and I'm going to teach you how to write that location. Calculate the velocity of each object, and then identify where the objects meet, if ever. So, first of all, location questions. Where is each object at 4 seconds? Let's go get our handy dandy pointer. At 4 seconds, we're going to look right here, okay? At 4 seconds, object A is 6 meters, and you have to say it's 6 meters from the origin, okay? Locations are relative. Saying that something is 20 meters from where it started is different than saying it's 20 meters from the origin, unless it started at the origin. So when you read a data table, every time, always state that it is this far from the origin, because that's how coordinates work. So object B would be 12 meters from the origin. Object C is 34 meters from the origin, and object D is 76 meters from the origin. Then we get into velocity questions. Remember that velocity is distance divided by time. It's how fast the object is going. So you can look at any 2 points you want to. You just have to really be consistent. So I always like to go from the beginning to the end. So object A went from 40 to 90. That's up 50 divided by 10 is 5. Object B started at 20, went down to 0. So that is a negative 20 divided by 10, which is negative 2 meters per second. Object C went from 50 to 10. That again is down, which is negative 40 divided by 10 is negative 4. And then object D goes from 100 to 40, which is down 60 divided by 10 is negative 6. Don't forget that the units are important. You need those meters per second for the velocity units. But then the other question I might ask you is, which one of these is going the fastest? Well, remember that fast is relative, and so you don't have to worry about positive and negative. You just have to worry about the biggest number. So believe it or not, object D is going the fastest because it has a speed of 6, whereas A has a speed of 5, even though they're going in different directions. Finally, then, we would talk about where two objects meet. Well, since only object A has a positive velocity, we can only compare it to the other three because they all had negative velocities. So the way you do this is to say, okay, where are the numbers the closest? And you may have to be real specific. Notice that at 0 seconds, we're at 40 and 50. That's only 10 apart. But then at 2 seconds, we're at 50 and 42. That's only 8 apart. Okay, so somewhere in here, we cross over each other. We had to have crossed over each other. So when you write this, you would write objects A and C will meet approximately 45 meters from the origin after 1 second, because it's not quite to 2 seconds, but it's not quite 1 second either. Okay, at 1 second, this would be at 45, and at 1 second, this would be at 46. So somewhere right after that 1 second is where they would meet.
Stand in the place where you live. Now face no. Think about direction. Wonder why you haven't now. Stand in the place where you were. Now face where. Think about the place where you live. Wonder why you haven't before.
All right, now this is kind of hard to see, and I'm sorry about that, but if you start with a graph, if I give you a graph, and this graph is a complicated graph, it's got multiple lines on it. But if I start with giving you a graph and ask you where is each object at 5 seconds, you just go down here to 5 seconds and follow it straight up. The orange line is at 6 meters from the origin. Notice I wrote 6 meters from the origin. Then I keep following the line up. The red line, right, is 10 meters from the origin. And I keep going up. The green line is 15 meters from the origin. And finally, keep going up. The blue line is 25 meters from the origin. Again, notice it's got to be from the origin, because locations are relative. Okay? Also with a graph, you can still find the velocity. Remember that velocity is the slope of the graph. It's the rise over the run. So what you have to do in order to find rise over run is you've got to find two perfect pretty points. And I'm going to try to make them as obvious as I can. Okay? So starting with the red line, this is the point 0.25 and the point 510. That's a distance of negative 15 over 5, which makes a velocity of negative 3 meters per second. The blue line goes from 15 to 25 in 5 seconds. That's a velocity of 2 meters per second. The green line goes down 20 in 20 seconds. That's a velocity of negative 1 meter per second. And the yellow line goes from 1 to 21, okay, which is a rise of 20 in 20 seconds, which makes its velocity 1 meter per second. So you have to be able to calculate the slope of the line, find two perfect pretty points, and do the distance divided by the time. Then you do have to be able to identify which object is going the fastest. Here it's going to be the red object because it was the steepest. Notice that it also had the highest speed, just in a negative direction. And then finally, where do two objects meet? Well, when you have a graph, it's way easier to go, okay, red and yellow are going to meet here, which is at the point 6, 8 or 6, 7, right? But you can't just say 6, 7. This isn't a math class. It's a science class. You've got to really give that location some meaning. So if this, our origin, is home, the red and blue lines, these two lines right here, red and blue, intersect right here. And we would say that they intersect 19 meters from home at 2 seconds, not the point 219. Now you could rephrase it and say at 2 seconds they will meet 19 meters from home. That's fine as long as you have the extra detail in there. Don't just give coordinates. So this is what you're doing on an assignment today. Thanks for watching.
Evil to you, but I